So let me walk you quick through where we are. We've got the front panel reassembled. We've got the hopefully repaired interface card in, the processor card in. And I went down into my collection and I pulled out this card here. And this is a 16K RAM card from the memory merchant. It's an MM16K14 card. It happens to be strapped for address C000 to FFFF. So the upper 16K of RAM is where it's strapped to. I'm not going to try to move the straps around to get it back down to address 0. We'll just work with it this way. Previous experience with this card has shown that because the heat sinks were so close and the capacitors here, that the card board doesn't like card guides. It just doesn't fit well. So I pulled the back two card guides off of the back plane here, as I knew we would most likely need to. So if I can get the card down in. Well, we're part way in. There we go. So the card is in. Go ahead and slide the card cage back out of the way. I dug up, hopefully here, we'll let the front panel somewhat sit level so you can see the front panel on camera as we work here. See if I can figure out a way to do this where it'll kind of sit here, hopefully level. Well, that's somewhat level. Let me check the camera and make sure we're in shot. It's not too bad. So let me go ahead and power the unit up. We've woke up. Let's go ahead and reset it. We're back to our reset. We can see that at address 0 it read all ones, and if we continue to examine from address 0, I expect that there's no memory. There's no memory in the system at that address. But let's go to address C 000 or 130000 in octal, and let's do an examine here. And don't see anything. That doesn't mean anything. Well, we're seeing all zeros there. Let's go ahead and come back here and examine. Let's set a bit pattern. And let's deposit that. Okay, that's a really good sign. We saw the bit pattern get set, and hopefully that actually got written into memory. So let's do a deposit next. The next address where I inverted them all. Let's get back to the address that we started at. Let's do an examine again and examine next. And there's our bit pattern. So we're actually talking to the RAM card. We've proven it here by writing into the first 2 bytes of it. If we get up all the way up to address 13336, that's one address away from the last address in memory. Let's go ahead and examine what's in there. And we'll write a pattern in here. We'll deposit that. We'll invert the bits here just to do it, and we'll deposit that at the last address of the machine. Come back to address 130 and examine, and we should find that original bit pattern we wrote. Next should change all the LEDs, and it does. Let's now go up to that next to the last address and examine, and we should see the pattern we wrote, and examine next should. So we're actually operational here. We are talking to memory. We're seeing the full 16K. That card in address space, which is really nice. Indications are we have an operational system. Until we actually execute some code in the 8080, it's going to be hard to say. And I'm going to have to look into how to do that next. But this is really good progress. The fact that we can see that memory card and we can talk to it in the back plane here, get it back into shot here, we can see this 16K memory card on the bus and talk to it's really nice. And you can see here we're already getting a really full machine. If I had an I/O card in here to provide a serial port, 4 slots, we'd be full. So 4 slots really isn't a whole lot in the grand scheme of things. There were 16 and 18 slot motherboards or backplanes in the era. I've actually got a couple here of that size. I think we looked at one in the first video in this series, possibly. I don't remember. But this is pretty cool. Actually pretty happy that it's working. So get back down to address here and do an examine next. And interesting enough, that memory woke up initialized with all zeros. So that's kind of unusual. Usually there's random garbage in memory. You know, it's holding the bit patterns we've written. You know, indications are we're okay. Start it running here. Yeah, who knows what it'll do. And again, it's just doing it. It's reading FFs off the bus and whatever instruction that becomes. I think it creates a loop or something. But you know, pretty cool. We can stop. We can single step. And we're seeing it just really cycle here on. So there's address 30, jumps up to this address, next address, back to 30. So it's in a loop here. Whatever that loop is. That's pretty cool. It's pretty cool to see this actually working. So really, I'm moving towards mechanical assembly now, getting this stuff all in the case. Got to think about that some more, but I'm going to call this a success at this point. We've got electronics and all 3 cards up and running. Well, the 2 cards that we built, CPU and front panel interface. I guess there's actually 3 PC boards with the PC board inside of the front panel. So I think with that, I will wrap this one up. Thanks for watching. We'll talk soon.